Hi, this is Leetcode question. Count stepping numbers in range. This is the last question of weekly contest number 1 or 3, 5, 6. In this example, low equal 1, high equal 231, and the answer is 31. Now to solve this question, assume we have number 1, 2, 3 up to low minus 1, then we have low up to high. So we have numbers from 1 up to high. Now the solution should be between the values low and high. This is the answer. Now to find this, let's find the solution for numbers between 1 and high and call it result 2 or R2, and let's find the solution for all numbers between 1 and low minus 1. Let's call it R1. Now if we subtract R1 from R2 minus R1, this whole segment minus this segment will give us this one, which is the answer. And notice that to find R1, we have here low minus 1. So the first thing to do is to subtract 1 from low, and this function does that. So if we have this number 432 minus 1 to return 431. If we have this number minus 1 to return, so from right to left we replace 0 with 9 until we find non-zero number, and we subtract 1 from it. So 400 minus 1 is 399. After subtract 1, now we find the result R1, then we find R2, and at the end we return R2 minus R1. Now notice that it's possible that R1 is greater than R2, and that's because we are doing mod here. Mod is 10 to the power 9 plus 7. Now because of this operation, it's possible that R1 is greater than R2. In that case, we only add the mod to R2 to fix it. So in general, the answer is the difference between R2 and R1. Now the question is how to find the answer for numbers between 1 and a given number. We will use dynamic programming to solve that. Let's take this number 2, 3, 1. Now assume we have some information, or we solve for this segment, and we are trying to solve including this index I equal 2. Now we need to solve for all numbers from 0 up to 2, and we need to take advantage of the previous solution for this part. And from this part we need two kind of information, TB1 and TB2. TB1 provide us with results for numbers between 0 and 9, and TB2 provide us with result exactly equal to the previous value. And so this value is 2. We iterate from 0. Now there are two possibilities for 0. Since the stepping number definition is we have an absolute difference of exactly 1. So 0 plus 1 is 1, 0 minus 1 is minus 1. Now minus 1 is less than 0. In this case, this is invalid case. 1 is less than 9. So whatever the solution for the value 1 at this part in this table, we will use it to calculate or to add that result to current index value 0. And the reason we use TB1 because the current value is 0, the current j is 0, so no matter what the value between 0 and 9 at this digit, still the number will be less than 231. This is why we are using TB1 in this case. Now the next j, 0, then 1. The two possibilities is 1 plus 1 is 2. Now what is 2 is less than 9? What is the solution for this value at the previous index? Also we take it from this table, and the reason we are taking from this table is the current value for j is 1, and no matter what's the digits value here, still the number is less than 231. Other possibility is 0. The same, we will take the solution for this 0 and add it to the solution for 1 at the current index. Then we have j equal to, now 2 equal to, in this case 2 plus 1 is 3. We need to verify if 3 is less than or equal to the previous value 3, not 3 less than 9, because if 3 is greater than 3 and the current value is 2, so to assume this is 4, this value 2 for x is greater than this number. This is why to calculate TB2 we need to check if the value is less than or equal to the previous value. So this is for less than and this is for equal. Now 2 plus 1 is 3, 3 equal to 3. In this case we use TB2 to calculate the current value for TB2, and this is what we said. TB2 is when the value exactly the same. Now 2 minus 1 is 1. 1 is less than 3. In this case we use TB1 to find the solution for TB2 because the current one is equal, and so we are calculating the result for TB2, but we use TB1 to do that because the current value is 2 and this is 1. No matter what is the value, if it's between 0 and 9, it should be valid. So this is why we use TB1 here. Let's see how this work. So initially we have these two tables, TB1 and TB2. So this is TB1. There's 10 columns. Each column represents a digit, 0, 1, 2, digit value 6, then we have 7, then 8, 9, and we have 3 rows, 0, 1, 2, because we have 3 digits in the number. This is TB1. Initially all the values are 0. The same for TB2. We have 10 columns from 0 to 9, and all the values initially are 0, and we have 3 rows. Each row represents a digit index. start with I equals 0. Notice that I equals 0 at the end. This is why we need to reverse the number first. So 2 3 1 after reverse becomes 1 3 2. Now this is I equals 0. When I equals 0 for TB1, the possibilities are from 0 to 9. So for every value between 0 and 9, for every j we assign 1. So this is 1. For TB2 we said we need the exact value, so only when j equal the current value is 1. So when j equal 1 we set it to 1, or other value in the row are zeros. Then for I equal 1, let's solve for TB1 first, and we start with j equals 0. 0 plus 1 is 1, 0 minus 1 is minus 1. This is invalid, this is valid. That means TB of the current index, which is 1, this one, of the current j is 0 here. We will take advantage of this value from the previous index here. So 1 plus 0 is 1. This is for j equal 0. For j equal 1, the possibility is 1 plus 1 is 2, 1 minus 1 is 0. So at 2 the value is 1, at 0 the value is 1. We add these to the current j. So here we have 2. For j equal 2, we have 3 or 1. This is 3 and this is 1, the same 2 2 2 2 2, and at the end 9, j equal 9. The possibilities are 9 and or 10 and 8. Now 10 is not less than 9, so this is invalid. 8 is less, so the value at 8 is 1, so this is 1. Now this is for TB1. Now to solve for TB2, only when j equal the current value, and the current value is 3. So when j equal 3, possibilities is 3 plus 1 4, 3 minus 1 is 2. Now this value, we need to check if it's less than or equal to the previous value. The previous value is 1, and we cannot just have any value greater than 1. So this is invalid. So as we mentioned here, the value should be less than or equal to the previous value. And the reason for that, remember the number is, the original one is 31. We calculated already for 1. Now if this number is greater than the previous one, that means this whole number will be greater than the whole segment, and this is invalid. This is why for TB2 we need to check if the value is not less than 9, but it's less than the previous number value. So 4 is greater than 1, so this is invalid. Also 2 is greater than 1, so this is invalid. So nothing happens to TB2. Next is I equal 2, and we start with j equal 0, we have 1 minus 1, this is invalid, this is 1. Now we are filling TB1. So this index, we add the value of 1, so this is 2. Then j equal 1. 1 plus 1 is 2, 1 minus 1 is 0. So at 2 and 0 we need to add these two values to the current index. 2 plus 1 is 3. Then at j equal 2 we have 3 and 1. 3 and 1, this is 4. Then this is 4, this is 4, and so on. Now we need to calculate for TB2 only when j equal to the current value. So this is 2. When j equal to, we have either 3 or 1. Now is the 3 greater than less than or equal to the previous value 3? Yes, it's equal to the previous value, and we said with the exact value we will use TB2. So 3 equal to 3. In this case this condition apply, and what is the value of 3 from the previous index? So from the previous index the value at 3 is 0. That means at the current index, current j, is we add 0, and so no change. Also for j equal to, we have 1. Now 1 is less than the previous value in this case, so this condition apply. We use TB1 to calculate for it, because the current value is 2 and the previous and we are checking for 1 is less than 3. So 2 1, no matter what this value, remember this is reverse, so 2 1, no matter what is this is still less than the number we are checking for, and this is why we are using TB1 to solve for TB2 in this case when it's less. So what is the value at the previous index with value equal 1? Previous index is this, j equal 1, or the value is 1, so the value is 2, the answer is 2. We use this answer 2 to add it to the current TB2 value, which is TB2 of ij. Now notice here what we add to the answer is when the value or the index is less than the last index. So for all the indexes less than the last index, the value we take from TB1, because no matter what's the value here between 0 and 9, it should be valid. So we add it to the answer, and notice here we check j should not be 0 because of this condition, should not have leading 0. So in this case this will be part of the answer, this one, this, all of these are part of the answer, because this is I less than n minus 1. Now at I equal 2, we check if the value is less than the current value. The current value is 2, so this is for j0, this is part of the answer, and this is part of the answer because this is for j equal 1. Now for j equal 2, we take it from TB2, this condition apply, If you do the summation for all of these, here we have 9, and here we have 16. This is 25, and here we have 3. This is 29, and here we have 2. This is 31. Notice this one is not valid because this is j equal 0, and here we check if j is greater than 0. So in total we have 31.